In this video, we will demonstrate fiber optic insertion loss testing using the Clearline SSF TKITP-400 testing kit on single-mode fiber terminated with LC connectors. Required materials are SSF-TKITP-400 kit with included light source and power meter, 2 LC to LC feed-through adapters, and 2 Simplex SC to LC single-mode reference cables for double cable reference testing. Cable under test. 1-click type cleaner for LC connectors being the 1.25 mm part SSF-1CLK-LC. 1-click type cleaner for SC connectors being the 2.5 mm part SSF-1CLK-SC. Using the light source and power meter. For full information on light source and power meter functions, refer to the included instruction manual. The light source and power meter can be identified by labels on the front of each unit. The keys and indicators included on both units are the following. Power button. This also controls the auto shutdown function. Wavelength. This key activates the laser and controls wavelength in nanometers. Backlight control. This key controls the backlight mode. Backlight indicator and backlight sensor. Keys specific to the light source are frequency modulation, controls laser frequency. Rated power setting selects default output power. Output controls raise or lowers output as needed. Keys specific to the power meter are units. Reference sets the current power value in decibel milliwatts dBm as the reference value. Save and delete. These keys allow you to save or delete records. Screen data. Items indicated on the light source screen are as follows. Battery level, wavelength, auto shutdown status. Auto off appears when auto shutdown is enabled. Modulated frequency, laser setting. Dashed lines indicate the laser is off. Output power. Items indicated on the power meter screen are battery level, wavelength, output power, auto shutdown status. Depending on settings, the reference value in decibel milliwatts, the data record number, frequency in hertz, or automatic wavelength status will be visible in the upper right-hand corner of the screen. Light source outputs. The light source has 2 labeled outputs. 1310 or 1550 nanometers is used for single-mode OS2 testing. 850 or 1300 nanometers is used for multi-mode testing. Note that the laser does not operate at visible wavelengths. Light will not be visible when the laser is active. To avoid the risk of eye damage, do not look into the laser at any time. Testing. Turn on the optical light source marked OLS and optical power meter marked OPM. Quick press power button on each unit to disable auto off function. On light source, ensure laser is active. Dashed lines indicate the laser is off. To activate, press the wavelength button. Set laser to 0 Hz. On both power meter and light source, for single-mode testing, set wavelength to 1310 nanometers. Set units on power meter to decibel milliwatts dBm. Remove dust cap from single-mode 1310 or 1550 nanometer port on light source. Remove dust cap from power meter. Remove single-mode SC to LC reference cables from bag. Remove dust cap from the SC connector of one cable. Clean end using 1-click type cleaner. Plug into light source. Remove dust cap from SC connector of second reference cable. Clean using one-click type cleaner. Plug into power meter. Remove dust caps from LC to LC feed-through adapter. Remove dust cap from LC connector on reference cable. Clean using one-click type cleaner. Connect to feed-through adapter. Repeat with LC connector on second reference cable. Join the two LC connectors using the feed-through adapter. Push the reference button to set reference value. Power meter will reflect a 0 decibel reading. Remove dust cap from second LC to LC feed-through adapter. Disconnect LC connector from the feed-through adapter on reference cable attached to power meter. Clean connector using one-click type cleaner. Plug LC connector into second LC to LC feed-through adapter. Clean LC connector of cable under test. Connect to LC feed-through on reference cable attached to light source. Clean second LC connector of cable under test. Connect to LC feed-through on reference cable attached to power meter. The new decibel value visible on the power meter screen is the test result. Loss budget calculation. Clearline advocates following established guidelines for insertion loss testing, such as those established by the Fiber Optic Association, and references these FOA standards in both equipment instructions and this video. Loss budget is the calculation of estimated loss of all connectors and cable in a link. Loss budgets can be calculated during design. In testing after installation, the actual loss is compared to the budget to ensure proper installation to industry standard. Each connector under test is allowed up to 0.75 decibels per the EIA TIA 568 standard. Single-mode fiber loss is calculated at an average loss of 1.0 decibel per kilometer for 1310 nanometer sources, or roughly 0.1 decibels per 600 feet. For multimode fiber, the loss is about 3.0 decibels per kilometer for 850 nanometer sources, or 0.1 decibels per 100 feet. In this video, the cable under test is quite short, so the cable loss calculation is less than 0.1 decibels. The loss calculation for the connectors is 1.5 decibels, or 0.75 decibels per connector times 2 connectors. The test result is less than 1.6 decibels, so the cable passes industry standards for link loss. Refer to the included Fiber Optic Association guidelines for further information, or visit the FOA on the web for further information on fiber testing or installation.